The aircraft carrier USS Gerald R. Ford began her first deployment on October 3, 2022. She departed Naval Station Norfolk in Virginia to operate in the Atlantic alongside Allied forces. This initial deployment lasted about 7 weeks. Her main goal was to test the ship's capabilities in a multinational environment and complete her post-construction trial phase. The Carrier Strike Group, along with escort ships, conducted exercises in the North Atlantic, practicing interoperability and power projection. On November 26, 2022, the ship returned to Norfolk, having successfully conducted flight operations and tested all systems in real-world conditions. In 2023, USS Gerald R. Ford set out on her first full deployment. On May 2nd, she left Norfolk for operations primarily in the United States' 6th Fleet Area of Responsibility. This 8-month mission included a transit to the High North under NATO command and port visits, notably to Oslo, Norway. There, she became the first American aircraft carrier in 65 years to enter the Oslo Fjord. The ship also took part in exercises across the European theater. Following the Hamas attacks on Israel on October 7, 2023, the carrier was redirected to the Eastern Mediterranean. Amid rising tensions, she replaced the aircraft carrier USS Dwight D. Eisenhower there to maintain stability and deter threats in the region. United States Secretary of Defense Lloyd Austin extended the deployment several times, including in November 2023, to maintain a military presence due to threats from Iranian-backed groups. During this deployment, advanced technologies like the electromagnetic aircraft launch system were tested in near-combat conditions. Over 10,000 sorties were flown from the carrier deck, with aircraft turnaround times proving significantly faster than on previous generation ships. On June 24, 2025, the USS Gerald R. Ford Carrier Strike Group departed Naval Station Norfolk in Virginia. Her goal was a scheduled deployment in the United States 6th Fleet Area of Responsibility to enhance readiness and security in the European region. The group included the carrier herself and escort ships, specifically Arleigh Burke-class destroyers. On August 18, 2025, they transited the strategically important Strait of Dover. This was the first such transit by an American carrier group since October 2024, when the aircraft carrier USS Harry Truman took this route. In September 2025, the group joined the NATO exercise Neptune Strike in the High North. American forces led a multinational task force in the North Sea, while other tactical groups operated in the Baltic and Norwegian seas. The joint training involved alliance partners like Norway and Denmark. The main goal was a show of force amidst regional tensions with Russia and China, which included large-scale operations in the Arctic off the northern coast of Norway. These maneuvers allowed them to practice joint naval operations, drawing on previous experience from operations in the Red Sea to improve air defense and strike capabilities. On October 24, 2025, the United States Secretary of Defense, Pete Hegseth, ordered the redeployment of the aircraft carrier Gerald R. Ford and its escort destroyers from the Mediterranean Sea to the Southern Command area, specifically off the coast of Latin America and the Caribbean. This was a significant part of a massive military buildup that included warships, submarines, and F-35 fighter jets, all aimed at combating narco-terrorism and disrupting smuggling networks. The journey from the Strait of Gibraltar, where the carrier was located as of October 1st, was anticipated to take at least a week. To maintain the integrity of the strike group, it was escorted by 3 destroyers. Venezuelan President Nicolas Maduro characterized the move as an attempt to create a pretext for war, although American officials stressed that the operation's sole purpose was to intercept drug cartels. This redeployment marked a substantial reinforcement in the effort to fight drug trafficking in the Western Hemisphere, as the carrier's air wing provided crucial reconnaissance and strike capabilities. In February 2026, after nearly 8 months at sea, the strike group was rerouted to the Middle East due to escalating tensions between the United States and Iran. On February 12th, it was announced that the Gerald R. Ford and its escorts had been ordered to join the Abraham Lincoln Carrier Strike Group, which was actively patrolling the Arabian Sea. The group crossed the Atlantic Ocean and entered the Mediterranean Sea around February 20th. By February 23rd, the carrier had arrived at Suda Bay on the island of Crete for resupply and refueling. It was scheduled to remain there for about 4 days before continuing its eastward journey. Following its stop in Crete, the carrier operated off the coast of Israel. As of March 2, 2026, as part of Carrier Strike Group 12, it was actively launching aircraft to support ongoing military operations. In early March, the Gerald R. Ford moved into the Red Sea. Meanwhile, the Abraham Lincoln Carrier Group was positioned off the coast of Oman, approximately 435 miles from Iran. This extension of their missions meant the crew's return to their home ports was delayed until late April or early May. In mid-March, while conducting combat operations in the Red Sea, a fire broke out in the laundry room aboard the carrier. Firefighting efforts lasted for more than 24 hours, and over 200 sailors required medical attention for smoke inhalation. At that point, the ship had been continuously underway for almost 11 months, making it one of the longest deployments since the Vietnam War. On March 23rd, the carrier returned to the naval base in Suda Bay, Greece, for damage assessment and repairs. Despite the incident, the carrier maintained full combat readiness and was officially still considered on active duty. However, as reported by Bloomberg on March 24, 2026, a report from the Pentagon's testing office revealed much more significant issues with the vessel. The document highlighted that even nearly 10 years after the carrier was delivered to the fleet, there is still insufficient data to fully assess its operational suitability. Major concerns included malfunctions in the electromagnetic aircraft launch and recovery systems, radar performance issues, problems with the weapons elevators, and the ship's ability to sustain functionality if struck by enemy hypersonic weaponry. These deficiencies raised serious questions about its long-term combat effectiveness and survivability. The assessment also pointed out that many of these issues had either emerged or remained unresolved since combat testing began in October 2022, and the prolonged deployment and deferred maintenance had only exacerbated the situation. The hull of the aircraft carrier USS Gerald R. Ford is 1,106 feet long. The waterline beam is 134 feet, and the flight deck stretches 1,092 feet long and 256 feet wide. That's about 3 times the length of a standard American football field. The deck is also significantly wider than one. Fully loaded, the displacement of the vessel reaches 100,000 long tons, making it the largest warship in history. The design features advanced stealth technology. Thanks to its special hull shape, the ship is less visible to radar, while remaining just as tough as the previous Nimitz-class carriers. 2 A1B pressurized water reactors power the ship. They generate a lot more electrical power compared to their predecessors. This is necessary to run high-energy systems like the electromagnetic catapult for launching aircraft. The reactors spin 4 bronze propellers through steam turbines, pushing the ship to a speed of over 30 knots. An efficient power distribution system made it possible to cut the reactor maintenance crew by almost 50%, and the nuclear fuel reserves are enough for over 20 years of continuous service without refueling. The USS Gerald R. Ford has a multi-layered defense system against missiles and aircraft. However, for offensive strikes, it relies mostly on its air wing. For self-defense, the ship uses anti-aircraft missiles, close-in weapon systems, and machine guns. All of this is tied into a single network that automatically detects and reacts to threats. The reliability of this defense was tested during trials in April 2021, where live fire exercises successfully destroyed training targets. The missile defense includes 2 Mark 29 launchers. They are armed with RIM-162 evolved Sea Sparrow missiles to shoot down anti-ship missiles and aircraft at medium ranges. Each launcher holds up to 8 missiles for rapid volley fire. These are backed up by 2 RIM-116 launchers, which hold 21 missiles each. They are designed to intercept short-range targets flying low over the water. The missiles use passive radar and infrared guidance, making them highly resistant to jamming. These 2 systems work together. The Sea Sparrow missiles have active radar homing and engage targets at distances up to 31 miles. Meanwhile, The short-range systems destroy high-speed and low-visibility objects at ranges up to 6 miles. Close-in defense is provided by 3 phalanx systems. Each of them is equipped with a 20mm M61 Vulcan multi-barrel gun. Guided by radar, it automatically tracks and destroys missiles or drones at a distance of about 1 mile, firing between 3,000 and 4,500 armor-piercing rounds per minute. They are supported by 4 25mm Mark 38 chain guns to fight surface and low-flying threats. There are also 4 50 caliber M2 machine guns to defend against small boats. Additional defenses include electronic warfare systems like the SLQ-32 for jamming, as well as flare and decoy launchers. The exact specs of these systems remain classified. All of this weaponry is a logical evolution of the systems used on the Nimitz-class aircraft carriers. The main focus here is on automation and reducing crew size for long combat missions. The USS Gerald R. Ford features a redesigned flight deck measuring 1,092 feet in length and 256 feet in width, optimized for efficient aircraft operations with integrated electromagnetic catapults and arresting gear. This configuration supports a diverse air wing consisting of carrier-capable Navy and Marine Corps aircraft, including F-35C Lightning II fighters, FA-18E and F Super Hornets, EA-18G Growlers, E-2D Hawkeyes, CMV-22B Ospreys, and MH-60 helicopters. Non-carrier capable U.S. Air Force aircraft like the F-15E Strike Eagle and F-22 Raptor, which lack arresting gear and reinforced structures for deck operations, have not been assigned to Carrier Air Wing 8 or operated from this ship, despite unconfirmed social media claims. Official U.S. Navy sources confirm operations are limited to carrier-qualified fixed-wing and rotary-wing aircraft. The flight deck enables sustained sortie generation rates of 160 aircraft launches per day during 12-hour operations, with a surge capacity of up to 270 sorties. Central to its aviation capabilities is the electromagnetic aircraft launch system, which uses linear induction motors to launch aircraft with precise control over acceleration, accommodating a broader range of aircraft weights, from unmanned systems to heavy fighters. This system offers improved reliability and reduced maintenance compared to steam catapults, achieving over 10,000 launches and recoveries aboard the Ford by July 2022. Complementing this is the advanced arresting gear, which employs water-based hydraulics and regenerative systems for smoother recoveries, enhancing pilot safety and equipment longevity. By April 2021, this gear had supported 8,000 recoveries. These systems contributed to the ship's flight deck certification in April 2020. The hangar deck, spanning approximately 899 feet in length, facilitates aircraft maintenance and storage with modular workspaces and automated handling equipment to reduce manpower requirements. Support for aviation operations includes 4 aircraft elevators for rapid movement between the hangar and flight deck, enabling high-tempo cycling during sustained missions. During its 2023 deployment, the crew executed 33,444 flight deck moves and 3,124 hangar bay aircraft moves, demonstrating the facility's capacity for intensive operations. 11 advanced weapons elevators enhance aviation support by transporting munitions at 150 feet per minute with an 11-ton capacity, which is over twice the speed and payload of Nimitz-class equivalents. This delivers ordnance directly to rearming stations on the hangar and flight decks. All elevators were completed and turned over to the crew by December 22, 2021, allowing for faster weaponization of aircraft and an increased operational tempo. This infrastructure supports the Ford's role in generating persistent air power projection with a reduced logistical footprint. The construction cost of the aircraft carrier Gerald R. Ford increased by approximately 23% from initial estimates. By 2017, it reached $12.9 billion, and the final amount totaled $13.3 billion. This made it the most expensive warship in the world. This cost overrun happened mainly because of problems developing and integrating brand new technologies. These included the electromagnetic aircraft launch system advanced arresting gear, and new weapons elevators, which had to be heavily redesigned right in the middle of construction. The situation was made worse by the Navy's decision to design, develop, and build the ship all at the same time, rather than sequentially. Since the systems had not been tested yet, blueprints had to be changed after the metal was already cut. This led to more labor hours and higher material costs. Schedule delays only added to the financial pressure. Construction pushed past its original deadlines because key systems failed their tests. Take those weapons elevators, for example, which were still unfinished even when the ship was handed over. The carrier was laid down in 2009 and commissioned on July 22, 2017, but it did not reach initial operating capability until December 2021. Its first deployment happened in October 2022, which was more than 5 years after it was officially delivered to the fleet. Because of these delays, the Navy accepted a ship with limited capabilities and incomplete systems. They did this just to stay within the financial limits set by Congress. Naturally, this led to extra costs after the carrier was already accepted. The United States Government Accountability Office also pointed out flaws in how the program was managed. For one thing, the cost estimates were unreliable. They were based on unrealistic expectations. For instance, they assumed an 18% drop in labor hours for the next ships in the class, without any historical data or independent reviews to back that up. Navy reports combined the costs for all the ships together, which hid the cost overruns for each individual carrier and limited transparency for Congress. This had to be fixed later through reforms. In response, the Government Accountability Office recommended creating verified, detailed cost estimates and conducting independent reviews before making big financial decisions. The Navy partially agreed, but by 2017, they still had not fully implemented these recommendations. Congress focused its attention on these ongoing risks. In July of 2020, the carrier program manager was even fired because of the constant failure to solve technical problems and keep to the schedule. But despite these measures, the next ships in the class faced the exact same rising costs. This raises constant questions about how the Navy manages risk while trying to balance innovation with financial discipline. The USS Gerald R. has encountered persistent reliability challenges with its electromagnetic aircraft launch system, or EMALS. This system has failed to achieve required operational targets, resulting in reduced aircraft launch rates during flight operations. These reliability issues persisted through the ship's 2022 to 2023 deployment. While the system did complete launches, it operated at rates below what was needed for full sortie generation, contributing to overall mission shortfalls compared to older carriers. The advanced arresting gear has similarly exhibited maintenance issues. Engine and wire positioning components required replacements and ongoing adjustments to support consistent arrested landings. During initial testing and early deployments, failures with the arresting gear disrupted recovery operations. As of fiscal year 2023, these problems continued to limit the ship's ability to sustain high-tempo flight cycles. The advanced weapons elevators, designed for electromagnetic operation to speed up the movement of munitions, faced significant delays and software integration failures. Only 2 of the 11 elevators were functional when the ship was commissioned in 2017. The final elevator achieved certification on December 23, 2021, after years of fixes. However, during the ship's first deployment in 2022, the system did not enable faster ordnance loading rates than its Nimitz-class predecessors. The ship's advanced waste management systems have also experienced reliability challenges, including toilet backups, overflowing waste, and plumbing failures during sea trials and early deployments. These issues were attributed to design complexities and required fixes during the post-shakedown maintenance period. The way these systems rely on each other has compounded risks to the reliability of flight operations. Department of Defense testing reports show that power generation and control software issues worsened downtime during maintenance periods stretching into 2019. By 2023, while cumulative launches and recoveries exceeded 20,000, the carrier's overall material readiness lagged behind benchmarks due to these unresolved deficiencies. The USS Gerald R. Ford's vacuum collection, holding, and transfer sewage system is a vacuum-based design adapted from commercial cruise ships to reduce water usage. This system has faced persistent reliability challenges. The narrow pipes and fragile valves are ill-suited for the high usage demands of a crew of more than 4,600 people. This leads to frequent clogs, valve failures, and zone-wide outages when a single component fails. The issues stem from both design limitations and improper use. Sailors have flushed inappropriate items such as t-shirts, socks, mop heads, rope, wipes, and other debris, worsening blockages in the sensitive vacuum pipes. During the extended 2025 deployment, beginning in June 2025, problems intensified amid a high operational tempo and crew fatigue. The ship averaged about one sewage-related maintenance call per day. Internal records showed 205 breakdowns over a 4-day period in 2025, requiring engineering teams to work extended shifts. Since 2023, external assistance for the system was requested 42 times, with 32 calls in 2025 alone. Acid flushes to clear the pipes cost approximately $400,000 each and could not be performed at sea. These ongoing sewage system failures contributed to unsanitary conditions, long lines for working bathrooms that lasted up to 45 minutes or more, overflows, and morale strain during the record-length deployment involving operations off Venezuela and in the Middle East. While some online speculation and opinion pieces suggested deliberate sabotage, like intentional flushing to force port calls or avoid conflict, Navy statements attribute the problems to improper materials being introduced to the system and design constraints. There is no official confirmation of coordinated sabotage or mutiny. A full system upgrade is planned upon the ship's return to Norfolk. The USS Gerald R. Ford is designed to take aircraft carrier capabilities far beyond the older Nimitz class. It features an electromagnetic aircraft launch system, advanced arresting gear, and automated weapons elevators. Together, these upgrades aim to launch 160 aircraft a day over a 12-hour period, with the ability to push that to 270 launches during a surge. Powering all of this are two A1B nuclear reactors. They generate up to 3 times the electrical power of the Nimitz class, roughly 600 megawatts compared to the older 200. This massive power boost allows the ship to operate with about 700 fewer crew members. It also leaves plenty of room for future tech, like laser weapons, giving the carrier better endurance and flexibility for long missions. To improve survivability, the Ford has a smaller control tower pushed further back on the deck and uses advanced radar-absorbing materials. This makes the massive ship harder for enemy anti-ship missiles to spot. Testing these new systems at sea has produced mixed results. In December 2020, the carrier set a single-day record, launching 170 aircraft and recovering 175 in just 8.5 hours. That's an average of 20 flights per hour, easily beating previous records for short bursts of action. However, government testing reports indicate the ship hasn't fully proven it can maintain that pace over extended periods. Much of the data still relies on computer simulations rather than real-world testing, and final approval awaits the complete integration of systems like the dual-band radar. During its 2022 deployment, the highly anticipated automated weapons elevators, critical for quickly moving bombs and missiles, didn't load weapons any faster than the older Nimitz-class carriers. This lack of reliability could significantly slow down operations in an intense combat scenario. Strategically, the Ford is the heart of a carrier strike group. It provides commanders with a highly adaptable tool to project power, deter threats, and respond to crises. This was clearly demonstrated during training exercises when the carrier teamed up with Allied forces to simulate combat in hostile waters. Naval analysts believe that once the stealthy F-35C fighter jets are fully integrated, the carrier will be able to maintain a much faster operational tempo, holding a strong advantage in air superiority. Still, government evaluations warn that because this is the first ship of its class, growing pains and delayed features, like incomplete self-defense systems, could limit its effectiveness early on. These issues likely won't be fully resolved until the next ships in the class are built. Ultimately, while the USS Gerald R. Ford promises a massive generational leap in efficiency and combat power, real-world data from its trials and early deployments shows the technology hasn't entirely caught up to the ambitious design. It will take time and continued investment for this carrier to reach its full strategic potential. As of March 2026, the Gerald Rudolph Ford is rightfully considered the most powerful warship in the world. It's the lead ship of the American supercarrier class. With a displacement of around 100,000 tons and a length of over 1,100 feet, it serves as the core of a carrier strike group. The ship brings together surface vessels, submarines, and aircraft, allowing it to project power from the sea without any reliance on land bases. This ensures naval dominance and enables it to carry out missions in the most challenging conditions, whether in the Atlantic, the Mediterranean, or the Arctic. New technologies give this class a massive advantage over the previous Nimitz carriers. The main innovations are the electromagnetic aircraft launch system and the advanced arresting gear. These allow for 25% more daily sorties. The crew's goal is to maintain a tempo of 160 sorties a day, compared to the 120 to 140 on Nimitz-class ships. 2 nuclear reactors generate 600 megawatts of electricity, which is 3 times more than its predecessors. This power is sufficient to run directed energy weapons, the latest radars, and automated systems. Thanks to automation, the crew size has been reduced by a quarter and now stands at around 4,500 people. At the same time, the ship can stay at sea longer while requiring fewer resources. All of this allows it to carry anywhere from 75 to 90 aircraft, including F-35C fighters, which are ready for precision strikes and gaining air superiority. In practice, these specs make the carrier incredibly effective. During its first deployment from October 2022 to January 2023, it operated in the Atlantic and the Mediterranean Sea. The ship conducted joint exercises with allies, including Canada, Denmark, Spain, France, Germany, the Netherlands, Finland, and Sweden. In August 2025, the strike group took part in NATO exercises in the High North. Operating above the Arctic Circle in the Norwegian Sea, the vessel showed it was ready to deter any threats amid growing tensions. That same month, the group passed through the Strait of Dover, proving its global mobility and support for European allies. And by October 2025, the carrier was deployed to the Caribbean. This proved once again its ability to adapt to new challenges at lightning speed and protect security anywhere in the world without relying on fixed infrastructure. During the construction, testing, and first deployment of the carrier Gerald R. Ford, a lot of technical issues came up. Specifically, these involved the advanced weapons elevators, the integration of the electromagnetic aircraft launch system, and the reliability of the modern arresting gear. Because of this, the United States Navy and Huntington Ingalls Industries decided to make changes to the next carriers in this class, like the John F. Kennedy, Enterprise, and Doris Miller. These changes were aimed at improving subsystem design, upgrading testing protocols before commissioning, and optimizing the construction process. This was meant to reduce the risks that usually come with the first ship in a series. The Navy also put a major focus on crew training and maintenance procedures for the weapons elevators across all ships of this class. The lessons learned from building the Gerald R. Ford were applied to the John F. Kennedy, which sped up module assembly and outfitting. For example, by mid-1929, the Navy reported faster progress on building the hull of the Kennedy and installing its subsystems. They used streamlined workflows that were developed after the delays with integrating the 11 advanced weapons elevators on the Ford. Similar improvements were rolled out for the Enterprise and Doris Miller. All the documented lessons from building the Ford, including strengthening supply chains and improving worker skills, became mandatory. The goal was to cut the cost of each follow-on ship by almost 50% compared to the final price tag of the lead carrier, which came in at $12.9 billion, even though the original plan was to spend $10.5 billion. However, the United States Government Accountability Office questioned the reliability of these financial estimates. They noted that by the time the main lessons were learned from building the Ford, the aircraft carrier John Kennedy was already in the late stages of construction. This limited the options for making changes, potentially keeping costs high and delaying the introduction of new capabilities. Despite all these adaptations, the delivery schedules for the next ships show that the inherited problems were never fully resolved. The delivery of the John Kennedy has been pushed back to March 2027. This was partly due to lingering issues with the elevators and general supply disruptions. Meanwhile, the delivery of the Enterprise was delayed until 2030 amid labor shortages and ongoing testing problems. Improvements carried over from the Gerald Ford, such as better living conditions for the crew and additional backup systems for combat, were fully implemented on the next vessels to ensure their long-term durability. However, current operational assessments continue to stress the need to practically prove the reliability of the ships before the entire class is fully deployed.